then I can do the timer.
No, I'll do the timer.
Okay. Okay. Now we general. I do the slides, you do the timer. Is that what we do? Okay. All right. I should speak into this microphone, I suppose, if I can. It doesn't seem to make a difference. Yeah. Okay. Welcome everybody to Sustain RG. It's my great pleasure to welcome you all here. We have a very full agenda, and we don't care about people who come too late to read the note well. That's why we start with the note well. Here is the note well. Read it very carefully. I'll give you 5, 4, 3, 2, 1. Everybody's read it. The session is being recorded, it said. That is an important part here, and you should be okay with this. There's also privacy code of conduct, note well, which you've probably seen before. Read it, but I'm not going to read it to you. We have to save time here. Intellectual property. The thing is that these slides are always the same. If you've seen it before, that's okay. Then I can go ahead. There's a slide on the goals of the IETF. There's an IETF primer for IETF participants. Go and read this if you wish. But don't expect me to read it all to you. Couple of administrative things here. These are links that are, well, again, I'm not going to read them to you, but these will be useful for people who want to maybe click on things. What? Right. What about the shared notes in the chat? There is.
It'd be very helpful if someone could, we have somebody who's already volunteered to help with the shared notes. But we also could use help with somebody curating the chat to ensure that things that are interesting and relevant on the chat session get embedded into our shared notes. Dave Aran, thank you very much.
Speaking of note takers, I don't see Marie Jose. Is she here? Okay. Thank you. Hello. Oh yeah, now I see you. Thank you so much for volunteering to help with this. Sustain RG vision. We contribute to the advancement of the internet as a fundamental part of sustainable and resilient societies and the planet through conceptual and evidence-based multidisciplinary research collaboration. Now you know that. Yeah, so what is this meeting about? What are we going to have? We're going to have talks on correlation of computation and networking with renewable energy availability, storage and management. These come from Herman, Noah, and Wen. Then this is an important announcement here. We made plans. We're going to have a workshop in Passau, which we're very thankful to Herman for hosting, on the 16th and 17th of July next year. So that is just the 2 days before the IETF. It's kind of an interim. It's like a meeting to talk about these things that are necessary to make the energy grid better, or maybe do things better in ICT based on signaling from the energy grid or signal back. Then we'll have talks on sustainability insights from adjacent domains, first on subsea cables from Hunter, and then on mobile network operator perspectives from Jesus. Something about the interplay, the linkage between company sustainability reporting and internet technical enablers from Jan. Some details on an experiment about path as opposed to just the device energy efficiency indicators from Alex, and an update on network architecture considerations for sustainability from Jari. You can see that you can almost read nothing because this is so dense. That's because the agenda is so full. So I'm also not going to read it to you, but there is one thing here which is important, which is why it's red. The timings that we have on the agenda, these include the discussion. So if you believe that your time slot is for yourself, then you have to skip a slide. This is and that includes the timing that we set with the clock. So if you present and you see the clock going down and it's getting close to 0, you're already over time, because then there will be no space for discussion, right? We will be strict about that because we have to. And that's it for the chair slide, I think. We can hand over to the first presenter, and I forgot what that is. That is Herman. Okay. Yeah. How do we, so now you said that I should do this. How do I? You're good with that. You can do it on my computer if you want. No. You can do it. Okay, great, thank you. Yes, you take this. I think you give the control to the clicker, right?
Yeah, first
I can
we
do the
have to
time.
share the slides.
Oh yeah, but how?
Michael is counting down to 4.
Yeah, yeah.
1.
I thought you do it.
My
You do it, exactly. We give you 10 extra
It's
seconds.
coming up.
Time
no
is
worries.
over already.
Yeah.
Okay. Now, okay. You should stand here,
Yeah, you have
and we are
control
happy
now.
that you do it. Yes, you have control now. I think that's how much time we need to give you.
Okay, thank you for being here. Just to let you know, Passau, Vienna, there's 2.5 hours by train, so it's easy reachable, so can easily combine. I'm continuing the talk from this morning. Some of you might have attended it, so it's a bit more specific with regard to specific use cases, incorporating data centers and battery storages. In particular, we have an experimental setting there where we're building data centers into windmills, where we're trying to exploit in real experimental setting what we have been talking about. Just as a reminder, in the past, we had the situation of large-scale generation units connected to transmission grid and top-down provisioning of energy supply to customers, to users. Now, we have a decentralized energy system with a lot of consequences. I talked about this morning. It's not just things changing, it's a qualitative change with many implications, meaning that former dependability criteria might not apply anymore. So we have a degradation of dependabilities. And this is at the core how to fix this using ICT, information communication technology. Now, doing this large scale means that power systems and energy systems depend on ICT more and more, increasingly so. But on the other hand, this vice versa relationship that ICT also depends on the power system, of course, obviously, and this vicious circle needs to be controlled and broken up. Now, with regard to energy efficiency, I would like to re-emphasize that we need to have a clear separation of concern. First of all, there is what's called the local perspective, meaning you have your site, your facility, your factory, your data center, and you're looking inside and managing all the resources inside. So that's the local perspective. But one should never forget the grid perspective, meaning that there's a connectivity to the grid where the residual load needs to be served or residual power needs to be fed in. And that's a big point of problem right now. It's probably the major concern of the transmission grid operators that with local optimization, one screws up the power grid with regard to creating congestion under adverse conditions that are really a challenge right now. And then there's the global perspective, which is the energy or power supply, which is a global criteria. The price setting is also done globally. And again, we're seeing a similar problem there. If you do local optimization, disregarding the global situation of energy supply, the balancing of energy, you could easily create havoc. Meaning that whatever you do locally, there must be clear interfaces to all energy suppliers, not just one. If there's several, then you have to have clear interface to all of them, plus to the grid, which is separate. It's a different thing, different entity that needs to be taken into account. On the other hand, of course, with renewable energies, we have continuous cost reduction, also with regards to carbon footprint and the cost that comes with it. The certificates being traded, which of course is a big relief if you look at renewable energies only. So it's a clear cost reduction factor that balances off. So on one hand, we have a decreasing energy cost itself, but we have increasing system cost, and the system cost has become the dominating factor. In particular, this is accounted for what's called grid fees. It all summarizes that, so we have to be aware of that. Now, the specific project we try to apply this is the idea to build data centers inside wind towers, which has the nice advantage that space is there already. You don't need to have a separate building. Of course, it's a limited size, so you can only build moderate-sized data centers inside, particularly in the context of high performance computing. moderate-sized data centers that are built inside. Plus, there's already infrastructure there. Normally for windmills, you of course, obviously you have cables, power cables, but also communication cables, so you can use them without separate infrastructure. And on top, of course, the tower itself can be used as a heat sink, meaning heat moves up and cools down, and you can use that in order to reduce the cooling cost of data centers on top of that. Plus, there's another thing that I mentioned before, that there is the danger of congestion, of overload in the power grid. And if you bring the load to the source, of course, you can avoid a congestion, because the power will never be fed into the grid that's been used at the place where it's been produced. On top of that, if you enhance the facilities with flexibility sources like batteries, you can even do much better. The batteries could be used in two ways. In one way, in order to compensate for local flexibility demand, because you have volatile sources. I mean, wind source fluctuate, and your data center, of course, needs to have predictable source of energy. Using the battery, you can flatten this out, meaning that, formally speaking, you have flexibility potentials you can use to smooth out flexibility requirements coming from the volatility of the source. Plus, you can use the battery also for external improvement of the services to the power system and to the grid. So, of course, it's a challenge, because you need to model this carefully, in the sense that you need to have something in place that helps you to make sure that the flexibility potentials are sufficient with high enough probability to serve all requirements. For that, we apply what's called network calculus. We know this from communication networks, where with the quality of service, you do a similar thing, where if you resources, you have quality of service requirements, and you want to assure that the quality of service that you want to achieve are met by the resources that are there. So we have discussed this many times, 25 years back, when packet switch networks were enhanced for quality of service. Now we can reapply similar techniques in this context, interestingly enough. So yeah, these are these objectives. So we want to maximize the operational sustainability. And inside the data centers, we're running AI applications, and of course they are energy hungry, which is of course the purpose in order to be effective in this context. Yeah, so the goal is to be congestion aware and to minimize the curtailments, which means that power would really be lost, because if the sources are curtailed due to congestion in the grid, then there's a huge amount of energy that would be lost otherwise, so use it as almost for free in the sense, right? Now, we're using some techniques. So we have the data center operating AI inside, but we're using also the AI for controlling the consumption of the resources. So it's kind of dual use, if you want, of AI. So we're using reinforcement learning for load distributions inside. So where we take into account computational resources, computational constraints like the resource available or not available, and then also environmental constraints like the thermal limits of the power, the weather conditions, all these kind of things need to be taken into account also. Plus the user constraints, because in the data center serve users, and you have to take this into account as well in your planning procedure. And for that, we are using green service level agreements, where customers, they can specify what quality of service they want to receive from the data center at what cost, right? If you're in a situation that you can exploit renewable energies, price would get down, and as such, you can benefit from such a scheme, also from providing grid support. As I mentioned before, again, this is for free energy. Of course, it would also scale down the cost of operating the data center. So we have AI for sustainability, and also also applying sustainable AI by exploiting the flexibility potentials with regard to execution of the data centers, plus other flexibility potential, which are, for example, batteries that are also incorporated. There are also some relevant drafts, IETF drafts, that provide some terminology that is of use in this given context. Now, I also want to emphasize that flexibility is the core of all of that. We need to manage flexibility because this is the basis for grid services, for ancillary service, but also for congestion services. It all boils down to having enough flexibility, and we need to have a framework in place, a computation framework with which we can do the calculations for making prediction and uncertainties that there's enough flexibility potential, we can deliver what we want to deliver. So as an example, so this is taken from PV context, but it's similar. So for example, you had a PV installation together with a battery, and you can use the battery manifold. So first of all, there's this volatility of, these are real data, the volatility of supply. However, this volatility depends on what time scale you look at your system, right? So if you average over a longer period of time, there's less volatile. If you look at smaller periods of time, it's getting increasingly volatile. And these are things you need to take into account. And this is subject to uncertainty, which means you need corresponding flexibility potential to match this. The battery itself could be used, for example, for economic revenues, where you go to the energy market, you sell and buy electricity depending on the price signal from a central market, like the power exchange. At the same time, you could balance these uncertainties and using the potential of the battery to smooth out thin, but you must make sure that you're using the resources correctly. So a few publications, also recent publications, provide you some insights how we're doing this.
If we want to have questions at the end, then you have only four more minutes.
4 minutes, it says 8 minutes.
Yeah, that's what I was saying, that is including the time of discussion.
Yeah, okay, so I have 4 more minutes for to talk. Okay, fine. Okay, so yeah, so we want to mitigate forecast errors. We have the possibility to be grid friendly, taking into account congestion, and also work on self-sufficiency simultaneously with these flexibility resources and calculating the trade-off. Right, so meaning that the wind park and the battery together is seen as one unit, and there's an interface to the system which consists of 2 components essentially, or more than 2, which is the grid and which are the energy providers. You have to have a clear interface to them, a load profile that needs to be negotiated upfront, and as the management of this entity, you have to adhere to this negotiation. You can do whatever you want inside, behind the meter, one could say, but you need to adhere to the profile in order to do not create havoc with the preceding grid and also with the energy providers, because they must balance out things that you would mess up, which of course is the trick. So now, is it really effective? Does it matter? Well, as said before, we try to mitigate congestion or curtailment. Now, a few numbers. Last year in Germany, we had about 3.4 terawatt hours of curtailed energy, which is a tremendous amount in 1 year in one country. Now, if you have a HPC data center with about 600 kilowatt, what does it mean? Well, we could serve 643 HPC data centers just with the curtailed energy. I mean, this is just beyond imagination. It's huge. Or if it doesn't tell you anything, then compared to the energy demand of Google, which is tremendous, it's 13% of the global Google energy demand, but just the curtailment in Germany last year. Right? It's enormous. So if I'm talking about energy efficiency, using this wasted energy would be highly attractive, right? So, come to the conclusions. Energy efficiency is not that trivial. I mean, it's not just saving energy, because you could create havoc with that. You need to have the system perspective and take the system perspective into account as well. Where there's the local perspective, that's the facility inside the resources. You need to manage them carefully, but not by ignoring the system itself. And the system consists of the grid and the global power system, where whatever energy delivery parties you have to take all of them into account. So for that to implement, we need a protocol, a communication protocol in place that's able to negotiate these kind of things that I've just mentioned. Plus, you need to specify service level agreements to the customer side on their quality of service they need, plus the economic contribution they're willing to accept. On the other hand, you also need to have a negotiation with the grid and with the energy providers about the load profile that both sides would be happy to accept. So that's really, really new. But with that in place, I think we can move forward, and we need to standardize this because this needs to be interoperable, and this could be a key contribution of the IETF or IRTF for that matter. And there's already some standardizations underway, ISO and IEC, that looks partly into some of these issues. And the Open ADR is a demand response standard that has been used for a long time now, and we can build upon that and expand it. That's my talk. Thank you very much.
Thank you so much for keeping the time. Yeah, one person in the queue so far.
Dirk Kutscher is an individual. Yeah, thanks, Hermann. Great talk. I was just curious. So some countries now have introduced dynamic pricing. So I know in Germany it's a requirement that the energy providers need to offer it. I just wanted to know what's your perspective on it. Is this helpful to create more flexibility potentials?
Flexibility potentials are always useful. I mean, so you need them definitely. And I mean, prices could be an incentive, but it could also be detrimental. It depends a bit because the prices for the electricity are set globally. If I'm talking about congestion, it's a local thing. It's the grid. I mean, it's if everybody rushes to the Autobahn, but there's narrow roads, I mean, there will be congested roads. Although you might you want to reach places that are highly attractive. Same thing here. There's advertisement of prices to buy and sell. You can buy at low prices, sell at high prices. But if you do that, everybody does it locally, you might end up in congestion, right? This is a problem. And actually, the grid operators are very mad about that situation right now, right? Because I told you these numbers are really, really striking. And this is real. This is the biggest problem right now because the local situation is not the same as the global situation. So yes, incentives are good, price incentives, but you also need to take the grid into account. And there's discussion now to have also dynamic grid fees in order to compensate that. Meaning while the global electricity price is an incentive, the local price might override the global price in the end. There could be other schemes. That's something to debate for us here is it pricing only, or should we have a congestion control algorithm in place in order to mitigate the congestion there? I mean, both ways are thinkable, but that's a matter of debate, a matter of modeling, and the best scheme, I don't know. That's something to see.
Okay, thank you.
Very, very interesting. I just have a question. Is there any negative side effect? Like, would the embodied carbon increase because you will need much more batteries in many small locations? Or when will this compensate, or this compensate after a week only of having been operational?
I hope not. I mean, of course, we want to reduce the carbon emission by using the energy locally where it's been produced. And of course, you're also saving transmission of power, which is a loss of about 5-6% anyway. So that's saved on top. Of course, plus if you do it in a grid-friendly manner, you would also save additional flexibility potential that would be needed otherwise, which of course is very, very costly. Now, as I said, the grid fees are by far exceeding, and the fees for services by far exceeding the cost of electricity itself. So that's essentially what we're paying for. Right
But
now.
I wasn't talking about monetary. I was in terms of carbon emissions, the
Right.
embodied carbon of producing much more batteries, because you will have many small data centers that are in the one farm. With this amount of carbon that will be created, will be generated to have this battery be compensated very fast due to the operational carbon savings that this is.
I mean, carbon savings are achieved by reducing the need for flexibility requirements because they are carbon intensive normally, because you have a fast ramp rate and a guaranteed power level, which it's hard to provide by renewable energy sources. So typically this resorts to some carbon intense energy sources. And to have smaller entities. Of course, in the ideal form, you would match the entities with the power being provided by the power source. Let's say if a windmill of 1 megawatt and you build a data center with 1 megawatt, would be perfect in the end, right? So that would be the ideal case.
Sure. Okay. Yeah, keep it short, please.
Yeah, you know what? I can just ask you later.
No, just please.
Okay, John Scudder, HPE. Yeah, I just would like to check that I'm understanding the assumptions correctly. You talk about using these, data centers built into the mast of the turbine to absorb energy that would otherwise be curtailed, right?
Right.
That I think means that you're assuming that the loads that the data centers are serving are completely dispatchable. Either that, or it means that all of that is sort of hidden inside and by the way, we do some magic stuff with AI here and batteries and so on. Is that, do I have the model more or less right?
I mean, it's not black and white. There's immediate cases also, right? Because yes, but if there's congestion, I mean, you will need to do everything in order to match the demand to the supply. That's why having additional batteries in place is a good thing, where you can make up for mismatches that would be there otherwise. Yes, of course. There's limits to what you can do. I mean, but yeah, you want to ideally match supply and demand on this scale.
Thanks.
Let's thank Herman.
Thanks very much, Herman.
Yeah.
No, welcome, and please.
Okay, can you just confirm that you can hear me?
Very well.
Very well.
Okay, good. Great, thank you. So today I'm going to talk about carbon-aware networking and some challenges and opportunities that we have. And
Sorry, Noah, we were hearing you well, but could you get closer to the mic? Yeah.
Is this any better?
Yes, thank you.
Okay, I'll speak slower. So, what is the carbon footprint of a network application? It is not as simple as people may think. It's not like we can just measure it the same way that we measure from plug in a data center. So let's say that I want to check if it's going to rain today. And obviously, if I'm in the UK, it is going to rain today. So first of all, I'm opening the app on my phone and I'm checking what is the weather. That sends a query to the base station and from it to multiple routers in different ISPs, going to a data center, and within the data center to the data center network, up the NIC into a server where we will have a CPU, storage, power supplies, and other components that contribute to the power, to the carbon footprint. And then again, we'll have emissions from getting the response. Now, obviously, we have a challenge here because there are multiple domains that are involved in the carbon that is emitted by this query. And at the same time, in every router that we have along the way, there are multiple flows that are contributing to the generation of carbon emissions. So let's think what is needed to reduce the carbon footprint of networks. We need metrics for accounting and reporting. We need routing and congestion control algorithms. So if I want to route from me to something in this picture, I can either take a single hop through a router that has high carbon intensity, or 2 hops through routers that are using greener energy. Which one is better? We need to think about capacity planning and workload scheduling, about the placement of workload across the compute continuum, all the way from the cloud to the end user. And when I'm saying workloads, it might be NFVs, it might be cached content. And we need to think, obviously, about standards. We need to think about regulation. We need to do commercialization of anything that we are doing here. We need to consider adoption and much more. And right now, I'm focusing this talk mostly on the operational emissions. But we have a few opportunities that we can leverage when we are thinking about moving toward carbon-aware networks. First of them is carbon intensity, the quality of the used energy, which is measured in grams of CO2 per kilowatt hour. Because carbon intensity is highly variable across geographic locations. So for example, within the UK, Scotland is likely to have lower carbon intensity than London. And this carbon intensity is also highly variable over time. So even within 1 hour, carbon intensity may change significantly. It also has a seasonality aspect. And it's not like you can say, well, during daytime, carbon intensity is low, and nighttime, carbon intensity is high. But still, the energy market is quite advanced, and we can predict carbon intensity 24 to 48 hours in advance, so we can take advantage of that. The other aspect that we need to consider is power proportionality, because ideally, the power consumption of network devices will be linear with the utilization. And while in CPUs, we are moving toward that, in the routers, we are not. So still 70 to 95% of power consumption will be the same, regardless of whether the device is idle or not. You can see in the figure on the right that we have the dynamic power, which is the blue part, that is affected by utilization. But everything else, which includes both static power and the power of the ports, doesn't change based on utilization. We should also consider what is the right device in the right place. So can we place compute within the network, for example, using programmable network devices? And how can we leverage the compute continuum to minimize carbon emissions? So based on some research that we have done, some preliminary results have shown, first of all, that if we just use carbon-related metrics in routing, we can save up to 7.5% in carbon emissions. And if we add traffic engineering to that and also turn off unused ports, we can reduce carbon emissions by up to 14.5% without changes to the infrastructure and while maintaining redundancy. We've also found, and that's work that was presented in NRW earlier this week, that carbon intelligent algorithms for content prepositioning allows us to save up to 64% of carbon emissions. And last, if we are using in-network computing for acceleration, the energy savings per operation are 3 orders of magnitude. And beyond that, also, when we reduce, when we move operations within the network, we also reduce data transmission because we terminate operations close to the source, and that further reduces emissions. But there are still important challenges that we need to consider. And I'm going to discuss 3 challenges: accounting for static and embodied emissions, data sharing across domains, and cached content and CDNs. Let's start with accounting for static and embodied emissions. Let's assume that we have a router that has 32 ports of 100 gig, and it consumes up to 1 kilowatt, and 80% of that is static power. That means that with 0 traffic, it consumes 800 watts. If our carbon intensity is 250 grams of CO2 per kilowatt hour, it means that the static emissions are 200 grams of CO2 per hour. Now, let's assume that we have only a single flow of 10 megabits going through this 3.2 terabit switch. Who accounts for the static emissions? I mean, I've got the 800 watts. Who needs to say that they are responsible for these emissions? Is it the ISP who has the router? Is it the user that is running the single 10 megabit flow and they account for all these emissions? Or maybe the user accounts only for the relative utilization of the router, in which case it will be a number that is 300 and 220,000 times smaller than accounting for all the static emissions. So there are different ways to account for static emissions, or who is responsible for the emissions while the router is not fully power proportional. Is it the ISP? This will certainly motivate moving toward more efficient network devices, but I guess that the ISPs in the room would rather not do it. Is it the users, and should we do it by the number of users currently using the router? It's relatively easy to implement, but as you have seen, it actually incentivizes using routers during peak hours, because then your static emissions cost is lower. Or maybe it is by user utilization, and that's harder to implement. And also someone needs to account for the unutilized part of the router. And when you think about embodied carbon can be amortized over the lifetime of a router, but then you have the same problem. How do you account for the embodied carbons? Who's responsible for it? A different challenge is data sharing across domains. So let's say that I want to route across the network, and I'm asking the ASs along the way to tell me the carbon cost of routing through them. In some cases, ASs may not want to share this data because of security concerns, because it might be competitive information that will allow someone to reverse engineer aspects of their network. ASs may also not know it, so their equipment might not support the hooks that are required to report it, or the accounting might be too complex. And also sometimes there may be more than one option. So there may be multiple routes through the network, and the traffic may be dynamic, so they can't really tell you. And actually, multipass routing is challenging also within a single domain where you are the administrator and you want to answer this question to yourself. I should say that, relatively speaking, data collection is easy in the sense that it's a technical challenge. There are different ways to do it. There's INT, there's IOAM that Alex will present later. The challenge that I want people to think about is more conceptual. How are we going to do it? The third challenge is cached content and CDNs. So I'm talking here about video streaming, online gaming, software updates, which are most of the traffic during peak hours. But often we are talking about content that is short distance from the user, which means that there's limited gain for carbon-aware routing, because there's only so many ways that you can make a single hop. You can think about moving the cached content away from the user, but this will affect performance, and this will increase the load on the network, which means that there will also be higher network emissions. And if we're thinking about AI and inference, it will only get worse as inference is moving closer to the edge. So, what are some of the next steps? For me, one of the things that we are doing is developing and deploying proof of concept tools across the UK. Specifically, there's a UK test bed called Joiner, where we are deploying some of the code that we already developed and looking to test it on it, as well as on 5G testbeds. If you are interested in carbon-aware networking, the first step for people is to annotate energy measurements with operational carbon emissions. So basically, you can retroactively take the carbon intensity during the time that you ran your energy measurement, multiply it, and you'll get the actual carbon emissions. Don't be tempted to use average carbon intensity. Average carbon intensity can lead to tens of % deviation from the actual carbon emissions. And if you know what is the PUE, you should account for that as well. And also, we should be aware that more challenges will arise over time. So these are just 3 challenges that I think that the sustained work group should consider, because a lot of them are not technical but are more conceptual. And I've already provided also some links where our repositories that have open material. And with that, I'd like to acknowledge my partners and contributors, and I'm happy to take questions. Thank you.
Thank you very much, Noah. Yeah, questions? Comments? Ideas?
Okay, maybe I can start. Thanks very much, Noah. If we try to connect Herman's talk and his warning to us about having a systems level view, and warning that if we focus on local optimizations, sometimes we might get it wrong in the end-to-end or systems view. Have you come across such challenges, and how would you see, like, rather than optimizing energy or carbon-aware decisions at node or path level, how do we make sure the overall impact is still positive?
This is an excellent question. I actually discussed it with Herman before. And first of all, given enough planning, we can improve. So we do need to work hand in hand with grid providers. And one thing that works in our favor is that network traffic is very much periodic. So you can predict what would be the amount of traffic at certain times of day and what will be the demand. So we can work together with energy providers. The other aspect of that is that if you are working with the grid, there is demand that is short-term and long-term. And there are different lenses to that, and we do need to account for those. But most of the things here, especially we're thinking about carbon intensity, which changes on a scale of every 30 minutes or every hour, do work well with with the grid, especially when we are thinking about the planning and the fact that we're predicting based on what carbon intensity will be ahead. We also need to work with the grid provider and see that this fits. Right.
Right. Thanks very much, Noah. Any other questions for Noah? Thanks very much indeed.
Yeah.
And thanks for joining remotely. Much appreciated.
Thank you.
Are you going to hand over to, I think, Hunter is next?
Yes, let me do that.
Thank you very much. And Eve, you're starting the clock? Okay, cool. I mean, I could do it. It's nice if you. I think you have to be removed from the queue. All right. Sorry, you wanna? Okay. With that, we hand over to Hunter Vaughan. Thank you very much for being online at what may be a weird time for you. I'm not really sure. Yeah. I see bright light.
Hey everyone, can you see and hear me okay?
Yes, we see and hear you well.
Great, okay. We'll enjoy that while we can. I apologize in advance. There's massive construction going on inside my house.
Hunter, we have an echo. Are you able to?
I don't know. Yeah, maybe. Yeah, turn down the volume a little bit on the, or get a bit away from your microphone, maybe.
I'm using headphones. Hang on, I'll turn them off.
Okay.
How about now? Can you hear me?
Yeah, that's a little better.
Okay, I'll push this away. How's that?
Yeah. Maybe even better.
Yeah, and you have slide control, Hunter. You can advance
sounds
your
good.
slides. Yep.
Yeah, I'm pretty amazed that people managed to include 67 slides, because I had to whittle mine down to 7 because of the size. So there might be some weird connections missing that I'm going to have to explain. And again, apologies for the sound of drills in the background. If it gets too bad or too disruptive, just mute me or let me know. there's not anything I can do about it right now.
No worries. It's all right now. I think it's all right.
All right. So yeah, thanks for having me, everyone. I feel somewhat like an interloper as I'm not really a computer scientist or an engineer, but I have been doing research for many years now in areas that definitely speak to the theme of this group. And so I'm excited to share some of that research and who knows, maybe to provoke some conversation or questions. So I'll go ahead and move through that. Part of what brought me here is specifically my work on subsea cables as part of the Sustainable Subsea Networks project, which is an Internet Society Foundation research grant that's run through the Suboptic Foundation with my co-PI Nicole Staroselsky at University of California, Berkeley. So basically the idea behind this is to work as boundary spanners in academic research, trying to somewhat step out of the ivory tower and engage industry stakeholders as well as communities, local communities, and policy makers, decision makers, and government. The first half of our grant, which was focusing, for those of you, I assume most people at this conference in this group are familiar with subsea cables that snake along the ocean floor, connect our continents, and mobilize over 95% of global data transmission. So what we're looking at really is ways in which primarily these impact local ecosystems, as well as the environmental ramifications of their broader maintenance and operation. Most focus in the ICT sector tends to be on data centers, as well as computation. And so we're trying to disaggregate and look at the impacts of this particular facet of global infrastructure. The first 2-year grant produced a best practices report, a policy white paper, a carbon footprinting method, and a renewable energy feasibility study. You can see here we also produced an online digital map that helps to highlight many of the sustainable best practices. And this is really everything from cable landing station operations, using renewable energy or opting for other sustainable practices, up through the end of life methods of cable recycling that are currently being pushed in the industry. I would like to highlight the notion that for me, this issue of sustainability and ICT is also one that is very much an issue of social sustainability. So while these infrastructures do impact both the benthic floor and coastal spaces, as well as generating lots of heat because the cable landing stations are often co-located with data centers, increasingly hyperscale data centers. They're massive energy guzzlers, and they also consume a lot of water in spaces that are often where there is water scarcity or access scarcity. So it becomes issues of social sustainability, not only in terms of the industry itself, which is largely white, male, and aging, but also in terms of the communities that it impacts, whether this is an issue of the use of space or energy equity, or whether it is disruptions in local landscapes that are important parts of intergenerational heritage. So for those of you that aren't familiar, telegeography is a really good place to go in terms of the mapping information of the global network. This is their 2023 map, which went a bit retro. Going back, there was actually, sorry, I don't use PowerPoint, I use Keynote. And so when I exported it as a PowerPoint, because that was smaller than a PDF, I lost text. And I should note, that the second phase of this grant, we're working specifically on metrics, where we're developing sustainability metrics for cable landing stations, recycling, and marine operations, to bring in industry members to help set their own metrics and transparency, so that at the end of this, we can sort of let go of the hand, remove the training wheels, and hope that industry stakeholders hold each other accountable. I am personally focused on marine operations, and I had a lot of other images here of previous maps, because if you look back historically, the map that you see here in 2023, and this is all fiber optic subsea cables, actually replicates centuries of maps from the empire building of the UK, specifically eastward through the US. And so most of the major traffic areas you see are the same that were marine shipping routes from the 1700s, and then telegraph routes from the 1800s, telephone in the 1900s, and then fiber optic by the end of the 20th century. And now today, you can see that they're really proliferating. As such, there is sort of cartography of imperialism and a act of neocolonialism that's attached to the growth of this sector, and also in terms of its access and its extraction of resources, whether that be water or energy, as is far more the focus of today's panel. I, in particular, am looking at the problems of the local community impacts of these cables, and their growth and the proliferation in general of ICT infrastructure, data centers, and things like that in Ireland, and just got back from 3 weeks of community-based research, where I went with an environmental social scientist, and we worked with a local facilitator in order to do community events to try to gain a better understanding of the community experiences of these infrastructures, both data infrastructures and the energy infrastructures that are being built up around them. And so basically the idea is to understand better what local communities want out of infrastructures and how they interact with local lands, heritage, or landscapes. So very much, in the same notion. Sorry, is this very loud for y'all?
A little bit, but
It's okay. I mean,
Okay,
we
feel free. You can cancel me and move on to the next person if it's.
you're understandable. I think.
No, it's
Okay.
understandable. Just
Yeah.
explaining to the audience that
I
there
appreciate
is some background noise there.
I assure you,
Sending a note off to.
it is as disruptive and
No,
frustrating.
it's
to me.
his. It's not here. So if you think that somebody's disturbing us here, it's not here.
It's here. It's in Miami. It's always in Miami. The disturbance is always in Miami, I assure you. So yeah, so the idea was actually to sort of dovetail the talk from looking at the legacy and the vestigial infrastructure connections between colonial infrastructures and 21st century entanglements between data infrastructures and renewable energy infrastructures, in correlation with certain Western scientific principles, such as the automation bias, which has very much been integrated into wide-scale acceptance of digital growth and dependency that we see with the design and planning of smart cities and things like that. And so I would, argue that many claims like this, we know are not accurate, right? That machines are not necessarily some sort of objective, neutral operation, but they actually embed into them the social biases of the people and the societies that design them, but also that they are, while perhaps increasingly used for climate science and for renewable energy systems operation, are nonetheless an energy sink. Like they're not actually saving us energy, even through high efficiency, because that just requires more high computation, which again requires more energy, and most of it is on dirty grids. And while you see some tech companies building out renewable infrastructures like Amazon through buying corporate purchase agreements in Ireland, they're basically funding the growth of renewable infrastructures that only feed back into Amazon Web Services. So a lot of big tech companies are doing this to try to rebrand themselves through corporate responsibility, but the reality is that they're just upping the ante of how much energy they need and will take. And this often happens in spaces like in Ireland of great energy equity, where members of the community can't actually afford to heat their own homes. And so there's this massive disparate, you know, disparity when it comes to the actual localized experiences of these infrastructures. Um, Now, in my other work, which used to be separate from my infrastructure work, and now is completely merging with it, which is on the environmental impacts of film and creative screen arts, you see that as the film industries start to digitalize and convert not just from like certain assets being digitized, like PDFs instead of printed scripts, through to a full-scale model of digitalization, they are in fact merging and becoming part of this wider digital network system. And so with the growth of virtual studios, with the growth of digital production, but also with the absorption of film studios by big tech companies, such as you see with, for example, like Amazon becoming not only a content provider or a content distributor, but also a content producer. There's actually sort of an emergence between these two. And you have this massive shift. The other slides that I'm missing involve the introduction of Avatar as the first supposedly digital, all digital film, and the growth of sort of a digital model for the film industry that perhaps is best linked to Netflix, I think, which itself now becomes a problem of of the energy needs and the environmental ramifications from the building of infrastructures to their maintenance to their operation of constant 24/7 high computation data crunching. And so again, while these industries or while these companies are definitely working hard to greenwash their public image, the reality is that they are still maximizing profit as their highest priority. And they, can list as externalities some of the social and the environmental impacts of that constantly escalating digital growth. So yeah, I think I only have a minute left, so I'm going to end there and can field any specific questions about some of the energy side of the infrastructure. There are pushes and that I've been part of to build out plans, for example, in local mobile production hubs like London to build out renewable energy sources so as to start shifting diesel generators and things like that. So everything from like on the ground film production to massive hyperscale data center operation, I think that we're seeing a sort of convergence between or among what used to be very specifically siloed aspects of digital media industries. I couldn't even fit my thank you slide at the end here. Apparently my images take up too much size, but I know that the team has my email address. So if they want to throw it in the chat, or I can, anyone that wants to reach out, I welcome that. And I welcome any comments or questions now. Thank you.
Thank you very much, Hunter. Great. Thank you very much for being on time. And with that, I hope that we get questions from anybody.
I'm in the queue. Hello, hello. Hi, Hunter. It's great to meet you. I should say that, I've been fascinated with this subsea cable community and then how it dovetails with the work on media and film for quite a while. One of the things that fascinated me and which piqued our interest here as we kicked off this group was a number of things. First off, sort of the interaction with an organization like the Internet Society and the Internet Society Foundation for grant giving in the sustainability realm. That was sort of the first thing that was like, oh, this is quite an interesting community to have leveraged that kind of grant. But secondly, the thing that was impressive to me was not only the first phase of the work, which was to sort of assemble everyone, but then a second phase of work, which was to how to scale and realize the aspirations. So my question to you is, first, what can you tell us about catalyzing all the stakeholders, and if you could give everyone an impression of who the stakeholders were that you brought to the table, because what often happens here in the IETF is that we're largely a group of technologists and we do interesting technology solutions, but then to really have the uptake of our solutions is quite challenging. So give us some insight into how you identified and cajoled a community to come together, a whole, subset of the networking topology community to come together to solve the sustainability problem. So that's kind of my first question. I'll let you answer that, and I have a second follow-up question.
Yeah, sure. Great question. And it's been kind of a wild ride and at times extremely frustrating, but also extremely eye-opening regarding the practicalities of this type of change. Regarding the Internet Society Foundation, we were in their first cohort in 2021 to 2022. They launched a Greening the Internet funding grant scheme. And so we were in the first cohort of that, and then they offered a second tier 2 years into that, which we also got. And so they've been really supporting. I would say actually that ours is one of the less aggressive. Many of them are specifically looking at issues of social equity and social exclusion, especially around digital access. And so trying to bridge issues of the digital divide. They've been very supportive and have a pretty diverse group of teams. Now ours, we benefit a lot because Nicole Staroselsky, who's the other PI on the project, she's been working in this area for like 15 years. And she came out with a book called The Undersea Network in 2016 that kind of rocked the world of media, film and media studies, as we started to tip more towards media as this larger understanding of the infrastructures, not just like the screen presentation and the production of texts. And so luckily she had a pretty well-developed base of relationships in that. And I would say that, my work is, I have a similar relationship more with the film and television industry. And my partnership or relationship building is actually probably more on the side of working with communities than working with industry stakeholders at this point when it comes to ICT infrastructure. And so I began building a relationship with communities in Ireland 4 years ago, spent a lot of time there 3 years ago, and worked with a local interlocutor and facilitator this time when we went back for a few weeks that included some outreach and then a couple of big events. So yeah, I think that whether you're trying to work with industry stakeholders or whether you're working with communities, it takes a lot of time, and it takes a lot of trust. I find that in general, the ICT industries are quite welcoming and very conversant, and they would like to do better environmentally, but it's an uphill process because most of them are answerable to monetary priorities, which makes it very tough.
Okay. Well, thank you for sharing this journey with us. Much appreciated.
Yeah.
Thanks for tuning in.
Thanks for having me. Thanks for including me.
Thanks, Hunter. Okay.
Thank you very much.
Yeah. Next, we invite Jan. Please, welcome.
Sorry about that. I don't know if you've noticed, but the talk slots are longer in the beginning and shorter towards the end here. So now we're accelerating one level. I got the opportunity here to propose to you as a research community 4 research questions that I would like to have the answer to. I'm very active in the green working group, where we need to have some input data from research, and so I'll try to make you interested in a few of these topics here. right? So I stumbled over what do you call it? A case study where one of these economists companies, it could be Ernst & Young or something like that. It's not them, but just to get an idea, some economists are studying or making a report on behalf of a client IT company for how much carbon emissions they are making, just like a lot of companies do. And I wanted to share the findings that I have from that case. So we have this XYZ Business Services that was looking at some IT company. It wasn't Spotify, but you get the idea if I put Spotify here. And they assessed, okay, how much energy and CO2 emissions came from their own data centers. That was quite easy. They looked at the energy bill of those, and you sort of get it from that. They were using some CDN supplier. I think it was Google, actually, it doesn't matter. So they were asking Google then, okay, how much emissions do you have on our behalf? And of course, they have lots of client equipment, end users that are using, let's say it was Spotify, then some sort of players are on the client side, and you can at least have an estimate of how much that is. Number of clients, Azure Power, GG factor for each region in the world, and you have some number. What remains then are the question mark columns. That's the network. So what did they do, this typical assessment economy company, for that? Okay, so they Googled the internet for scientific papers. So that's the reputation of scientists is high in demand for these guys. So they found something called Piccolo et al. 2018. And in that paper, they can find a number, 0.1 kilowatts per gigabyte. Oh, sorry, gigabit probably, yeah. So they went along with that. They did not realize that this number is for a radio network. So they sort of plugged it in here and said, this is the thing. And they, without understanding it, they said, put a 0 on the fixed network and up to the CDN network. And not only that, they picked the radio for they picked the number for the radio only. They assumed linearity. So if you send more bits, it's going to be more CO2 emissions. They didn't take the pipe size into account at all. Like if Spotify has a 100 gigabit wire into the network, the operator will have equipment in the network there that can take in 100 gigabit, whether they use it or not. And most of that power is going to be used regardless of what they do. So maybe that's a factor to take into account. And they didn't look at all into how many hops or what the distance was from their data center via CDNs to the end customers. Is that around the corner in the same city, or is it across the globe? Wasn't factored in at all. And of course, they only looked at this radio network then, so they didn't look at routers, load balancers, firewalls, and CDN network, whatever. So I think we can agree that their assessment wasn't all that good. You with me? Yeah, good. I'm used to having more response from people, so.
Yes,
Yeah,
we're here.
great.
We're waiting.
Okay, so my first proposal to the research community is, what should this look like? How should we actually tell them to compute these numbers? This is happening today. People are doing computations, but all these economists are doing it differently and not so well. I've tried to confirm this with this was one case study that looked more in depth, and I saw these problems, and I've tried to verify if the situation is similar with other cases, and it seems to be. Not exactly the same, perhaps, but in the similar vein. So we have to come to agree on a sort of formula or method for how to compute this. That's my first proposal. By the way, it was great to see the presentation by Noah just a few minutes ago, which brought up a lot of these questions that I've been struggling with a long time already. Very good. I hope you will join this effort. Next thing is attribution. Okay, so I said they should contact Google or whoever is running the CDN here and ask how much are you emitting on our behalf. but how do they know? The supplier, how would something like Google figure out how much they are emitting on behalf of a particular customer? There's no easy way to see that on the equipment. So I think they are probably doing some sort of economist thing. This customer is 2% of our revenues, it's 2% of our emissions, or something like that. But I think we can do better. And I hope you could be interested to take a look at what that might look like. And of course, this is going to the economist. It has to be easy both to understand and to apply. It can't be too detailed, but we need to get the incentives right. That's the most important thing. The numbers can be wrong, but the incentives on the market need to be right so that people want to save power or save emissions. Third, we have the reporting part. So, okay, these numbers that are coming from the XYZ Business Services Company is going to be reported up into the, in my case, then the European whatever, mechanisms for reporting. There's something in the US, there's something in Japan. They happen to be different, even if there are some parts that are sort of similar. And this may not be a traditional research problem. How do we report? That's already set in rules. But whatever we come up with for formulas and ways of working with this, we have to make sure that the economists are aware that this exists. We have to make them understand it well enough so they can use it. They need to be made to care about it. And they cannot be too hard because they will ignore it if it's too hard. And because of that, we need to actually get in contact with our target audience. That's these reporting people. Make sure they understand these things, and we probably have to learn a bit from them as well. So it's not that maybe the traditional, you don't write a paper about this, but you need to get in contact with these people to be relevant to them. And just earlier today, I found this thing. I'm subscribing to the Greenhouse Gas Protocol newsletter. And earlier today, I got their latest news flash. And it is one of the items in that was this Carbon Accounting Conference 2025 in London, the 7th of October. I intend to try to get in contact with these folks. But it's I'm not as impressive as IETF. So if some people here, maybe you guys too would join me, and we can contact them together and say, hey, we want to talk to you guys, maybe participate, but also maybe be part of the program, or at least set up a meeting or something like that. And the fourth one is the reduction aspect. Once we know what we have in the network, we also need to have some sort of control and reduce, be able to make sure the devices are using less energy. And if you look at the laptop markets or the desktop computer market, in the 80s and 90s, if you turned on the computer, it was running on full power. It was powering the CPU was running at maximum speed. The memory was used, all of the memory was used. The scheduler wasn't really aware of anything. But then the laptop came around, and suddenly it was important to save power. So now in a typical laptop operating system, there's at least 50 different things they do there to save power. CPU frequency scaling, turning off memory banks, turning off or going to low power mode on USB devices that are connected, and so on, scheduler, blah, blah, blah. We need to do this in the networking industry as well. In some cases, the CPUs that we are using have some of this functionality, but we have turned it off. And for many line cards and other things, there just isn't anything like this at all. And we have to come back there. But anyways, much of this is happening on the millisecond scale. So we cannot really have some controller sitting in the central office somewhere telling devices, now you need to go to low power mode or something. It needs to be done mostly locally. Some aspects maybe need to be on the network level because there's no point in powering this one down unless that one is also doing it and so on. But for much of this, these decisions have to happen locally. So then we have to be able to express to the devices, okay, I can accept these terms right now. If the load is going below this threshold, I can accept that you go to some sort of low power mode. And then the bandwidth, of course, I configured 100 gigabits, but I understand it will be lower. So what can I accept? And maybe there will be some cases that it takes time to go back to full power again. I might lose packets, and I can say that, yeah, if you're saving power, I can lose this amount of packets. That's all right. I'm fine with that because the gain in reduced energy is worth it. But then we need a way to express this to devices. And this is something we are struggling with in the green working group right now. How do we actually create a way of expressing our SLAs basically towards the devices? So I want you to come up with some way to figure out some sort of policy framework for how we can express what we can tolerate in loss and so on. Yeah, this is it. I think we should, any comments or questions on any of this?
So I understand that the challenge of trying to ask all the elements that are involved in the delivery of a service to a user in the intermediaries is challenging. And if you miss something, it can be, it can significantly reduce the viability and the usefulness of the results. I'm wondering if it would make sense to start asking the inverse question instead, which is you ask somebody, how much carbon would be saved if you as a customer went away? And I think you'd find that this is not a symmetric question. And the latter question may in many cases be more interesting, or at least as interesting. And I'm curious if anyone's interested in looking at the problem from the inverse perspective.
I think it's quite strongly related to question number 2 I proposed there, but yes, it's perhaps a different perspective on it.
Marisol, please.
Hi, Marisol Palmero, no affiliation. Thank you, Jan, for the perspective. And I think we are kind of in link. I want to make a call. You were talking about an event that is coming soon. But I really believe there is a problem of how Scope 3 is accounted. Many companies are following the greenhouse gas protocol that I think we should influence a bit more because from the engineering perspective, there are different aspects that will not align with networking, right? This effect of the double accounting and how companies are reflecting the CO2 emissions, how those are accounted. I think from an engineering perspective is something wrong, and I would like to propose if there is something for this group as well to do and influence these aspects. Thank you.
I think long term we may be able to do that, but right now the GHG protocol is what everybody's using, so we have to live with that in some way.
Thanks very much. We have Adrian in the queue. Yeah.
Hi, Adrian Gallego from DT. So first of all, thanks a lot for the presentation. And I would like to raise 2 flags here regarding reduction. So I think that at the end, we need to reach a threshold between sustainability or energy consumption reduction and performance. That is something which is really relevant for critical use cases, such as reducing the energy consumption in the RAN. At the end, we are dealing with big hardware devices, which are not really made in such a way that the energy can be reduced in an optimized. So for example, in a general purpose service, you can go to the C states and reduce the energy consumption, you can manage somehow. But at the end, I think that second flag then is that we have a real dependency on vendors. So as far as we are not able to push vendors to try to drive this kind of ideas, we are not going to be able to really implement this kind of energy reduction overall in our networks. Yep.
This took a few decades in the laptop market, so I'm expecting it's going to be somewhat similar, maybe faster. We have some more inspiration here, but we have to get started, and we need to start with defining the theoretical foundation for it, and maybe policy languages and this sort of thing, I think.
Fully agree.
Thank you very much. Let's thank Jan. Great talk. Oh, Jesus, your turn. Welcome.
Just want to remind everyone to sign up to the meeting in Meet Echo, the blue sheet reminder There are lots of colleagues in the room, but the participant list shows much less. Please. Thank you.
Okay. Hello, everyone. This is going to be like more of a measurement presentation. This is a joint work with some folks from India. Maybe I'll leave it here, it's easier. Yeah, so I'm going to show a real use case of the evaluation of RAN sustainability in a production network. Oh, sorry. Yeah. Oh. Okay. Okay, so this is a real measurement that happened in a European country. So, I mean, just for motivation, I think the motivation is quite clear, but just to put some numbers to talk about the magnitude. So MNOs in general consume around 320 terawatts hour of electricity in 2022. This is 1.3% of the global electricity usage, or it's basically, this is more than the total yearly consumption of Spain and Portugal together. And within this, from this consumption, the RAN is the largest energy consumed. In general, regardless of the MNO, is around 70%. 70% of the energy consumption is from the RAN. And depending on the energy source, as many people have already presented here, this demand leads to significant CO2 emission. And this, of course, has a huge environmental impact. So, I mean, this is not new, and the GSMA climate tax action was created already a while ago, and there is some vendors that have committed, like, okay, I'm from Telefonica, I know Telefonica wants to be net neutral by 2040, Orange the same, and of course there are vendors like Nokia, Ericsson, they all try to reduce the energy footprint. In general, from a more research perspective, there have been two approaches that they've been taking. One is measuring energy consumption from different levels, and another one is trying to optimize it. From the measuring perspective, there have been papers that show how to evaluate energy usage at different levels, so at the network, at the core, at the antenna. There is also different energy consumption assessment depending on the type of population, so in urban settings or in rural settings. Right now, I think there are different RATs. There are 4 RATs already running in parallel, and there is people trying to measure what is the energy consumption in 2G in comparison to 3G, 4G, or 5G. And there are also, because some people release data, there are energy models to try to create and infer what would be the energy consumption depending on the different levels of utilization. And of course, now the recent work tried to do carbon footprint estimation on these different consumptions. No? And then at the optimization level, I mean, there is a lot of work that have tried to predict traffic, because this is quite fundamental. If you want to later optimize or create any energy saving policy, you need to know what is the incoming traffic to take an action that doesn't affect the performance. There is also different levels of shutdown at the base station level during low demand periods. And there is also some more sophisticated machine learning techniques like reinforcement learning that try to optimize the policy. But in general, we found that a lot of this work is based on simulation and it's not real setting, not real measurement, or at least at a large scale for a long period of time. So this is kind of what we wanted to do. We wanted to do some sort of reality check. I think for the best of our knowledge, this is the first work that goes at the European level in a large scale, measures the impact of energy saving policies. No, in general, I mean the papers that I mentioned go much more in detail, but we benchmark 5 different energy savings strategies. We measure different things. So we measure, for instance, the cell down time. We also measure the energy consumption and how this affects for the throughput. No? And we also showcase what is the trade-off between energy saving and end user performance. And at the end, I show some recommendations for future energy saving strategies and for general for this community, which I think is going to be relevant. So broadly speaking, energy saving policies are at the RAN. So RAN are highly redundant. So each of these gray dots symbolize an antenna. So an antenna has high frequency capacity and low frequency capacity. And this is how it's configured. Within this, the implementation of energy saving policies, the most typical and most MNOs, what they do, they have this threshold-based energy saving. So it's something relatively simple, no? But there are these components that I think are relevant for people to know. The first one is power groups. So it's a cohort of antennas in an area. So basically it's one of the pie chart. That's what we consider a power group. So it will always have one band that is for the coverage and other frequencies as well. Okay. So besides the power groups, we have utilization. Utilization it can be measured in PRV or TTI, and this is for each power group. And then we define two thresholds. One for when the policy will be on, and another one when the policy will be off. And then two other variables are the activation time and the deployment time. So this is an example. No? So in gray, it means that the policy was not active, it was active only at night. And then within, sorry, maybe I didn't mention, the activation time means for how much time the utilization has to be at that level for the policy to be on. For instance, 5 minutes. If the utilization is below this threshold for 5 minutes, then the policy activates. And the same for the activation part. So this is more or less how it works. And the deployment time is, as I say, no. So you can do the policy for 24 hours, you can do it for 12 hours, only at night, depending on how conservative you want to be.
Jesus, if you want to have questions also, then you have 4 minutes really.
Yeah, okay.
Yeah, that's including time for questions.
Okay, maybe this is very fast. I'm just going to describe the stuff, and then if you want questions, I show the results. So the special characteristic of the trial, so for trials, you need to define a special. So where do you want to do the trials? You do these trials before do any deployment. So for instance, you try in dense areas and in sparse areas. In this one, you have 5 antennas for every kilometer. And in this one, you have 1 antenna every 5 kilometers. And then you define different temporal characteristics. Okay, I say it can be 24 hours or it can be 12 hours only at night. And this is the typical approach where you increase, so you become more strict in order to save more energy, but potentially affecting the performance. This is the data set that we use. We can go in detail, but in general, something about the deployment. We need to know how the network keeps changing. We need to know about KPIs, and we need to know about how people move around. So some initial results, basically something that is interesting is increasing just 2% the threshold. So the threshold when the activation, the energy saving policy activates, you pass from a mean downtown of around 70% to almost 90% in the case of sparse regions. No? And this is just to showcase that in some cases there's 24 hours and in others it's only 12. Maybe this is the good one. The different policies, in comparison to not having any energy savings, you can reach a saving of up to 34%. So it does save energy. The way to measure the energy savings, we need to have an inference of how much would have been if there was no policy. And for this, we use this work that was recently published in Connex. And then I think this is interesting, just to showcase how much over-provisioning there is. So the F1 is the frequency that can never be turned off. And then F2 and F3 were the frequencies that were actually turned off during the trials. And then the F4, that was the high capacity, was also never turned off. As you can see, with around 20% of the capacity that you have in the deployed, you cover quite a lot. And only 40% is necessary to cover the peak that we found in the trials. So there is a lot of room of service for saving still that we haven't achieved. No? And actually, we found that the most savings occur at 5 a.m. and the least savings is around 5 p.m. regardless of being sparse or regardless of being a rural or a urban setting. And then here I was just emphasizing what you guys know, that even if you have policies that are energy efficient, that doesn't mean that you are carbon aware. You can see here that at the same, we look at a particular week and we found that the carbon emissions vary significantly. So some days we were being much more carbon efficient than others with the same energy policy. So if you want to be carbon aware, you need a completely different policy than just the energy consumption. And just quick takeaway, basically only having on-off threshold is suboptimal. We need to reduce the granularity. Potentially we need to have more dynamic thresholds. We need to take into account the neighbors because there are some use cases where we affect the neighbor antennas. And there is, of course, big opportunities for carbon-aware policies. So I think that's it. Sorry, I think 15 minutes was too little.
Good. Thank you very much. And questions, comments, suggestions, ideas? Did we lock the queue or is nobody?
I might ask, so to tie this back to some of the other conversations we've been having about carbon awareness, is that something that you're now headed into? And do you have any preliminary results?
We are trying to do that. We're considering the carbon awareness, but I mean, in general, the difference between being energy efficient and carbon aware is with energy efficient, you directly affect cost. So it's very easy to sell. We will reduce your cost if you implement our policies. With carbon awareness, so far, there are no incentives, at least monetary, to be carbon aware. It's only, and that's why I mentioned at the beginning, well, the GSMA has a group and many companies want to be net zero, but the time frame is a bit far, no? It's 2040.
And is there enough variance in the carbon intensity within a region of cells? I don't know the answer to that, but if every cell tower has its own solar or batteries that were charged when there was renewable energy, will you have the same kind of variance that we saw in the picture of the UK, for example?
I mean, the UK is a particular case because it depends on the country, no? So Spain has everything centralized, so it doesn't matter so much. But the UK, yeah, the north has completely different than the south. And you could have, and also I show that rural and urban, this is in a European country that might apply also to the UK, has completely different levels of utilization. So you could optimize much more carbon in certain regions than others. Yeah, much more.
Great. Thanks.
Jesus, I have a question as well. In your list of lessons learned, you're saying neighbor-aware decisions. Do you plan to include other operators' availability or status in the area to make a coordinated decision, for example? But is that
so you mean other MNOs, for instance?
Yes.
We want to, but this is, I mean, from a technological point of view, I think it's possible. And we are doing some work trying to accomplish this. But yeah, from a more, it's not that easy for MNOs to collaborate between, even an MNO that have many virtual MNOs, you don't see the data at all.
So would you propose that would make a significant difference and there should be investigations?
For sure that it will affect. I mean, if you know the status of the antenna, for the end user, the performance will be much better. And also to create better energy models. If you create in a federated fashion, it's much, I mean, first the community will benefit because the models will be open, and also we will be more accurate, no? Because usually different virtual MNOs target different populations. So some are mostly young people, others. So you will get much better representation of different levels of utilization that makes a much rich model.
Okay. Thanks very much.
Thank you very much. Time to hand over. Well, you do. Thank you so much for sharing. You take this thing and microphone. Yes.
Okay, so I've seen some familiar faces from the audience, and then for those who don't know me, I'm Wen Tai from the University of Oslo, together with Michael Shafiko all together. And then we are talking about our proposal towards free final grain carbon maps. Yes. So starting from what we have right now is carbon information maps are commonly used in carbon path-aware routing, such as Scion. I know they use APIs to get readings from electricity maps so that they can make choices in their path selection in interdomain routings, interdomain routings. Some of the available platforms that we are having, they do obtain real-time carbon intensity estimations, and then we do have more static, let's say, reports from a national level that's being renewed annually or monthly. So those platforms and the reports shows us estimation of the carbon intensity. They take data from open available databases that contributes cross-border energy trade, local cross-border energy trade, aggregated carbon consumption, and some of the less consumptions in a certain area. If those data are not complete or some of them are missing, electricity maps use machine learning techniques to estimate their aggregated power generation data. And then as for the important part is those platforms and reports are very widely cooperated into companies, technical strategies, policy makings. However, those platforms which gives estimation of the carbon intensity are largely, almost all of them, are depend on a great breakdown for different type of fuels based on a national or zonal level, let's say a bidding zone from different countries. And those levels of breakdowns are too large, too general, and less representative for our local users. If we want have a specific path selected within a country or within a province of the country, then it is urgent for us to have a more finer grain map for carbon intensity informations. And then when we are using, when those platforms are using carbon tracing to define the origin of electricities within cross-border power trades, they almost always assume proportional shares. That's not being the realistic case in local power consumptions. So we might not have the same share of powers for different type of fuels from the national grid, and at the lower local levels. And on top of that, we do have hourly local production data and the electricity price available, but those data are not being used. And then also we have no reflection of the priority on the renewable energy dispatch from different country policies. So we start with what we have right now. We are targeting towards freely available databases first. We have this awesome open infra map that provides location information for energy infrastructures, telecommunications, utilities, and the network and the grid and then power grid infrastructures for the globe scale. And then we have population as our proxy data to bring the national level carbon intensity to a lower local level carbon intensity as a proxy data. So we use population data from the UN and from different countries of the Bureau of Census. Actual extra location information can be get from Google Maps. And then we do focus our data right now on the European region. So most of our data are taken from ENSO with local power generation at a city level, some demand, and then also the trade informations. There are also platforms available for the UK and the parts of Canada. Finally, we plan to do our validation between our results in a region and the estimated result from, let's say, electricity maps. Yes. So we can I can quickly go over the current model, and then our focus is much of the less the problem that we're facing. Our current model will split cities into self-sustaining and and those cities that cannot cover their local demand by their local productions, and then. The two models that we have right now speaks for themselves, but more or less we have those challenges on our way. So first of all, the local consumptions for industrial usage are not in our picture. So we would really appreciate any comments suggesting on top of that with available reliable databases. Secondly, the price of electricity needs to be considered, but it's a complex interplay of so many factors. And then we are instead of using the price directly into our model, we're more or less thinking about using a price-related index to reflect the importance of price, and also giving suggestion to our local users when they're making when we are making recommendations for locations, and then also path selections for load switchings. So additionally, we do acknowledge the different policies in different countries regarding the priority of renewable energy dispatch. So we have to adjust our model of consumption according to different locations. And yes, I have 3 minutes for questions. And that's our contact information.
Jan.
Thank you. I love the electricity maps and I love the work that you do, but I have a caveat, and that's if you're trying to use electricity maps or this sort of data for attributing that company such and such in city this and this is responsible by this sort of definitions, I have a problem. Because what happens in reality is that these companies are buying electricity on the market from a particular supplier, and I personally buy wind power electricity specifically, and I'm paying a premium for that, and I don't want to be considered to be using grid average in Stockholm where I live. I have much greener energy than they have, than most people have around them. And the same thing for the other way around. Some people are maybe buying the cheapest electricity they can get, very dirty, and they should not be considered to have grid average just because they happen to live in Stockholm. So we need to look at the contracts, and that is driving the right incentives for people to do the right choices. So incentives is the key thing here, and we need this electricity maps and this average things is good for having a great understanding of what the situation is in different locations, but you can't use it for attribution.
That's also being touched on in our questions over here. Is we have to consider how to incorporate power purchase agreements between different power suppliers to our consumers. But the thing is, even if we do have special agreements between those two ends, the physical power that we're getting are either from the grid or some supplies. We can talk a little bit more under the table after the session. Or you do have a question afterward.
I'll just say, it's all about incentives. That's the important thing.
Okay. Anything else?
Yes.
Hello, I have a question online actually. Yeah, so very interesting too. I can imagine these challenges are quite hard to resolve at the moment. Did you say you are using the sign architecture, if I understood correctly at the start of your presentation? How did you get the network topology?
Can you repeat your question again? Sorry.
If I, in the first slide, when you said you are looking for this topology, you are looking at a sign architecture, or is it a freely available data set you are using for to calculate the map which you are showing in the graph?
Excuse me, could you try once more and speak up a bit? It's very hard to understand you. Or maybe just write the question into the chat.
What I will do is I will catch hold of the speaker in a few minutes. Okay, that's not a problem.
Yeah, I mean, maybe put it in the chat and then you can answer offline, and we could maybe already hand over to the next in that case. So we take that to the chat room.
Okay, all right. But yeah, thank you for having me over here.
Thank you very much.
Thanks very much.
Thank you very much.
Okay, can you hear me?
Hi, Alex. We hear you. Well,
okay, excellent. Okay, good. So yeah, so I'm presenting on basically a technical solution or technical problem that we've been looking at, how we could actually obtain green path metrics along networking paths for sustainable networking, well, using in this case an IOM aggregation trace option. And this is joint work with some folks from OST in Switzerland, who have also built actually a proof of concept and so forth for this idea. Let me see how I
can you speak up a bit, please?
Oh, I'm not sure. Let me put the mic closer to here. Is this better?
A bit, yes. Go ahead.
All right. Okay. So yeah, I think in a couple of the presentations we already talked about the need for metrics, and of course metrics are very important because we need to have observability to perform any type of assessment and optimization and so forth. Most metrics are of course typically obtained from on-device instrumentation. What we were looking at is basically other metrics that go beyond the device, specifically actually for paths and path segments. And we wanted basically to see what metrics can be defined and how can we obtain those metrics for possible applications, such as how can I select among the greenest among multiple possible paths, or also to actually optimize the paths themselves. Let me see how I can advance this. Okay, so this was basically our problem statement. We wanted to basically look at these path metrics, which are composed of metrics from the individual hops which would be encountered across paths. So there you could, for instance, think of things such as basically energy usage and so forth that each hop encounters. You can basically normalize them by interface speeds and by environmental ratings of the devices and so forth. But then you need to still, but this is basically only on a per hop or on a per node basis. You would still need to obtain basically this metric across the path. You still need to accumulate or aggregate these metrics across that path. So the question is how we could do that. Well, one thing is we can retrieve it by the device, but then you face the issue of, well, how do you actually access all the devices? How do you deal with issues related to path congruency and so forth? So therefore, we ruled out this option. Another option would be to use in situ OEM data to collect data from each hop, but again, this comes with its own problems. So the solution we came up with was basically to introduce a new aggregation trace option for in situ OEM, where instead of collecting individual data records, we would basically aggregate the data across the path. So using a simple aggregation function, and examples of such functions are, for instance, finding the minimum, the maximum, the sum, the average, things of that nature. And then basically each hop, as a packet traverses the network, will basically update this aggregate by looking at the prior aggregate and basically adding or aggregating it with its own local metrics. There are a number of use cases for this. Of course, focus here is on sustainable networking, but there are potentially also other uses, such as for just in general, if you want to identify bottlenecks and outliers across a path, or aggregate packet dwell times and so forth. All right, so again, the basic idea is basically, so you have the packets, an encapsulating node initializes and adds those fields. Each of the nodes being traverses that is being traversed updates this aggregate, and then basically at the end of this, you basically strip again the aggregate off and you export the result, and you have already basically the aggregate without needing to perform any further processing, which you can basically directly use for whatever function that you want to have. All right, so there are, well, you will find actually details of the proposal in a draft. The link is actually here in the accompanying slides. In the interest of time, also let me skip over this and just also mention basically the POC implementation that was built. You will find this this implementation on the link that is given here on GitHub, which basically implements this option using P4 on BMV2 switches, and in addition to this aggregation trace option, what this POC contains is basically is an export function using IP, exporting the using the aggregated data using IPFix to a collector, where it is then basically put into time series databases and then charted using Grafana, or using basically visualized in multiple forms. And basically, so that's the work that we're doing, looking at these path metrics. The next steps are, of course, to build out this POC, to use it actually for more continuous monitoring functions, and also perhaps to try to use this data, to use the path data to go into the pollution aware or carbon aware networking, perhaps some of the similar type of functions that Noah was presenting earlier in the session. And we would also like actually to try to standardize the aggregation trace option. So so we've taken this to an internet draft, in a different working group. And anyway, so I just wanted to raise awareness for this work. And if you're interested in this, please contact me. Please contact us. Okay. Thanks. That's all. Questions?
Thank you very much. Comments, questions, anything? Anybody? Yeah, we have Eve.
Okay. Thank you so much for this talk. I have been thinking for a long time that path-related metrics of aggregated values it would be very useful. And so I wonder, is it your intent to make the aggregation function field, which has many bits, something that's extensible? Because although you can imagine some useful functions, I imagine other people will come up with other algorithms that might have utility for their applications that may not exist yet. So the question is that meant to be an extensible?
Yes, it is meant to be extensible. So basically, extensible actually in multiple ways. One way in terms of the actual aggregation function that is being used, as well as for the data items that are being referenced. There are some other proposals going on actually right now, also regarding IOAM. There's also a new template option. There's a draft for this that's being proposed. Depending on how that goes or how that develops, we may need to align. We will align with this basically as needed. But the intent is absolutely to have it extensible as you described.
Great, thank you.
Hey, Kunze, RWTH Aachen University. Just basically hooking onto the last question on your slide. So I'm interested in collaborating and will reach out after the session. Thanks for the interesting talk.
Excellent. Thank you.
Any other questions? Okay. Thanks very much, Alex.
Thanks.
Hi, Ari. Welcome. Slides coming up.
Yeah, thank you. So this is just a brief update on something that we talked about in the previous Sustain RG meeting. So it's about sustainability in architecture. Basically, the idea is to try and provide some concrete design advice to protocol designers and network architects to help them build more sustainable solutions. And yeah, what happened since last IETF? We've done a fairly big rewrite of the document. It's now maybe, or at least it should be more focused on what's actually about the architectural aspects and less on general sustainability issues. We've split the document in a different way. It's structured now as having one part that's about understanding, so measurements, for instance, and then action, which is about the rest. We've also categorized our recommendations in two buckets. The first bucket is this actual advice to protocol designers. And that's about things like, what should you take into account in your architecture for measurements or dynamic scaling and so forth. And then the other bucket is kind of our, we saw that there's a need for some new work. And that's actually why I'm here in this research group meeting. So let's talk about that a bit more in a second. So we have some asks, two asks. And the first ask is that please review our latest draft version. If we missed something, there's something extra or something wrong, probably is, then please let us know. We'd be very happy to get feedback on this. But the even more important thing for this crowd is that we thought that there are some areas where we cannot have yet like a recommendation that do this, Mr. Protocol or Mrs. Protocol Designer, because we don't fully understand that particular aspect, and more work is therefore needed. And some of those items are, in our opinion, research-like topics that perhaps we all could work on and make some experiments, for instance. So two items. The first one is about transport algorithms. So the idea here is that, of course, you would like to save energy or be conservative in resource usage. But the problem is that you have multiple different possible strategies and multiple criteria to look after. So strategies could be like, send as quickly as possible, and then nodes can sleep more, or maybe you need to send us, in a regular paced manner as possible, and then you don't have too many high peaks that could indicate that the network is overloaded at some times and needs to be upgraded, even though in this particular case it would not be the reason for upgrade. Or perhaps you could have some mixed approach where you pump as much data through that you can without causing any buffering delays. Or maybe it's a strategy where you decide based on some extra information that if the network nodes can go to sleep, then I do A, and if they can't go to sleep, then I do B. Anyway, so an area where more work is needed. The other topic is encoding. And there's two sub-questions here. One is, of course, like a big fraction of the internet is video. And that's its own topic, obviously, that needs to be, or it's worth improving by itself. But is there some other thing where protocols might use ASCII fields instead of binary fields? And of course, there's many such cases, but we are looking for a case where it could be easily improved, the encoding, and it's significant enough traffic in the internet that making a change would actually change something real. And that we haven't found, but it would be interesting research to do. And the second thing is about these new designs for coding based on AI technologies like semantic communication or compression. And here the idea, of course, is that you take an input and move, convert it to a semantic description of this is what we're seeing, and then on the other end you recreate the image or whatever you were sending. And that has a very interesting trade-off that, well, maybe now you can send less bits, but then you have to do compute to arrive at the semantics and then to recreate the thing. And we don't believe we know exactly where the, what's the right thing here. So it would be really interesting for people to do like actual experiments and measure and compare. So that's it. And if you have feedback on our draft or any other discussion, then the research group mailing list is as good as place as any, or send mail directly to the authors.
Thanks very much, Jari. Any questions?
I have one.
Yeah, Michael.
Yeah. I'm curious about the status of this draft, like in terms of next procedural steps. Are there any?
I'm curious about that too. Like we haven't spent a lot of time thinking about the process, but we started this as a as part of the IAB program activity, and IAB does have an ability to publish documents that are architectural advice for the community, and maybe Suresh wants to complement that.
Hey, Suresh Krishnan. So to that point, right, I think the goal of this is like whenever we are ready to take this forward is to put it in front of the IAB to see if we can get consensus from the IAB to adopt it as an IAB document. In that case, it just continues on the IAB stream as an informational document. That's one way to go. And if there's like stuff that we need to take out, like, so part of the stuff on the rewrite that Yari talked about, some of the stuff went into the appendix because it was not like actually actionable on things, right? So I think once we do that, my co-IAB member, Mark Nottingham, who's the other lead on this program, would take it forward, since Yari and I are authoring this, so we would kind of like keep arm's length away from like the IAB adoption process on this.
Thanks, Suresh.
Thank you, Suresh. Thanks very much, Jari.
Yeah, thank you. Thank you.
So, thanks very much for your attendance. The session is closing. I want to kindly ask all our presenters, if they are not already part of the Sustain mailing list, please join the mailing list so that the community can reach you through a broadcast and everyone is aware of the ongoing exchanges. And we hope to see you again in Montreal. And as was shared earlier, we are planning our workshop in Passau before Vienna meeting 126. So please watch out for that. And any other closing remarks, co-chairs?
Sure. I just want to thank again both our note taker, whoever is out there contributing, as well as Marie-José, who raised her hand first, and also to Dave Aran for helping us with the chat session. And thank you all for participating, both folks in the room, as well as those who are remote, especially those of you in time zones where it's inhospitable. I'm often that person in the inhospitable time zone. So we appreciate it very much. Thanks for participating, for all your great questions.
Yeah.
Thank you. Meeting closed. Bye.
You two are so great. I didn't even get to do much because you were doing the timing, you did everything already. Great, thanks.